Prove that for Z1 and Z2 in the complex numbers, the sum of those two, Z1 plus Z2, and then take the conjugate of the answer, is the same as taking the conjugate of Z1 and adding it to the conjugate of Z2. So to do this, we're going to let Z1 be A plus BI, some random complex number, and Z2 be X plus YI, some other complex number, where A, B, X, and Y are all real numbers. There's a definition of complex numbers there. So starting with the left-hand side, Z1 plus Z2 conjugate is equal to, that's A plus BI plus X plus YI, and then the conjugate of that. Grouping together the real and imaginary parts, this is going to be A plus X is the real part, plus B plus Y times by I is our imaginary part. So the conjugate of this whole thing is A plus X, take away B plus YI. And now we need to show that this is equal to this. Now we could start with this side and show that we get the same thing. I'm going to go a little bit more directly. I'm just going to rearrange this into A minus BI, and then plus X minus YI, which is equal to Z1 conjugate, because this is the conjugate of Z1, plus Z2 conjugate, because this is the conjugate of Z2. And there we have our proof. As I said, what we could have done is we could have taken this right-hand side and expanded it and showed that we get the same thing as we did here. That would also be a valid approach to show that both sides expand to give the same thing. But I went for a slightly more direct approach here.